If you've ever wondered how robots learn to walk, or how ChatGPT was actually trained, this is the core technology behind it. Most people are familiar with value-based methods, where an AI calculates the score of every possible move. But today, we're looking at policy search, a method where the AI directly learns the best behavior without needing to calculate a score for every single state. Think of it like playing rock, paper, scissors. If you always play rock, you'll lose. A computer, using a deterministic policy, a set rule, is easily exploited. To win, the AI must be stochastic. It has to learn to be random and unpredictable. This is where policy search shines. It allows AI to navigate complex, blurry situations where it doesn't have all the facts, like a robot that can't see around a corner. The lecture highlights the breakthrough reinforce algorithm from 1992. Here's the story of how it works. The AI runs a full episode of a task like a robot trying to walk across a room. It records every move it made. At the end, it looks at the total reward. If the result was good, the algorithm uses a score function to go back and slightly increase the probability of every action taken during that run. But there's a catch. Time only flows one way. A decision you make at second 10 can't possibly affect the reward you got at second 2. By leveraging this temporal structure, researchers can reduce the noise in the AI's learning process, making it much more efficient. This exact logic is what powers modern marvels like Proximal Policy Optimization, or PPO, the very algorithm used to fine-tune ChatGPT to speak like a human. Whether it's teaching a quadruped robot to run faster by slightly adjusting its joint curves or training a language model, policy gradients are the engine of modern AI.